I said, okay. So, L'Hopital's rule basically says that, what page are we on? We're on page 70? Okay, we're on page 70. So L'Hopital's rule basically says if you get one of these indeterminate forms, and later we'll work with things that aren't 0 over 0 or infinity over infinity, but if you get one of these two indeterminate forms, then what you can do is the limit of this rational function is equal to the limit of the derivatives of the two rational functions. So easier than trying to factor and remove poles. If you take the limit of the derivatives, then you can get the same answer as the limit of the original function. So for this one, if I plugged in 2, I would get an indeterminate form of 0 over 0, which means that there is potentially a hole, right? So then before in unit 1, we factored it, removed the 0, removed the hole, and then solved for where the limit existed, right? Yes? Okay. So L'Hopital's rule, and let's just do one of these problems before I show you the explanation why it works. But L'Hopital's rule basically says that, all right, if I plug 2 in and I go 3 times 2 squared minus 7 times 2 plus 2 over 2 minus 2, that equals what? 0 over 0. Now be careful, because you don't want to say this limit equals this. It doesn't equal this. So don't write this equal sign, just off to the side. Evaluate the function at the point that you want to find the limit of. And this 0 over 0, you want to say, if you're doing a proof on a free response, you want to say that this is in indeterminate form. And then you can say, okay, now I'm going to do L'Hopital's. So this must be here to say, all right, I've gotten an indeterminate form, which means that I can apply L'Hopital's rule. And so L'Hopital's rule says that if I take the... You should say it. So now we can take the derivative of the top, which is 6x minus 7, and then take the derivative of the bottom. We're not doing quotient rule, we're just taking the derivative of the top and then the derivative of the bottom. The derivative of the bottom is 1, and I can plug 2 in now, and 6 times 2 minus 7 is 5, right? So the limit of this is 5. You could have gotten the same answer by factoring, but L'Hopital's is sometimes easier, especially when you get to functions that aren't just polynomials or whatever. Okay, let's explain why you need to write 0 over 0, because this is extremely necessary. They won't give you, they'll take off points if you don't say that it's 0 over 0, indeterminate form. And so the reasoning why is you have this limit as x goes to some value a of f of x over f of a, or f of g of a, let's say g of a, g of x. All right, so we start with that. Now what tells me that I can apply L'Hopital's rule is that if I plug in a for x, I would get 0. And if I plugged in a for g, I would also get 0, right? All right, doesn't matter what these two functions are, but let's say this is the graph of f of x, and this is the graph of g of x. Okay, The only thing we know is that at the point A, what is my y value? 0. Okay, so they can be any function that you want them to be, whatever. They just have to go through 0 on A. And then this one, maybe it looks like this. Whatever it is, it goes through 0, right? Okay, at this point right here, A, if I made a tangent line, let's make a tangent line at A. What's my tangent line equation at A? Y minus equals the derivative at A times x minus A, right? Right. Or I can write y equals f prime of A x minus A plus 0. Hold on for a second, just bear with me and let me write f of A on this side. It's really 0, but we'll write f of A. Now if I make a tangent line for G at point A, then it's y equals G prime of A times x minus A plus G of A, right? Yes? Okay, at this one singular point, at this one point at A, this limit could be the slopes of each of the tangent lines. F prime of A, x minus A plus f of A. And G prime of A, x minus A plus G of A. But the reason why you can apply L'Hopital's for when it's 0 over 0, because if f of A is 0 and G of A is 0 as well, then I have this limit with all of this gone, right? And then what happens? The x minus a's go away, and there's your limit, L'Hopital's. That's why you can take it of the derivative, right? Okay, so that's why L'Hopital's works, but it only works in the case where this is 0 over 0. Because if this is not 0 over 0, then you don't have factors that can cancel, right? Do you see what I'm saying? Okay, that's why it's important to write 0 over 0 or infinity over infinity to prove that this is actually an indeterminate form and I can apply L'Hopital's. All right, let's keep going and do the next problem. So if I plug in 3, I get 3 plus 3 over square root of 9 minus 5 minus 2. So I get 6 over 0. Well, do I apply L'Hopital's rule? No, so automatically, what do I just say? That it's undefined or does not exist. Because what do I have if it's 6 over 0? This is an asymptote. Right? So if it's an asymptote, my limit as x goes to 3. Okay. For 3, let's plug in -2. If you want to, on your calculator, you can store -2 in for x and then just type this top in with x's in, and then type the bottom in with x's in, and make sure you get 0 over 0. But I think it ends up being 0 over 0 for this one. So if that equals 0 over 0, what I have is an indeterminate form. Which then means, all right, cool, I can apply L'Hopital's. By L'Hopital, that means that this limit goes to, limit can be rewritten as, and we just do the derivative of the top over the derivative of the bottom. We don't do quotient rule. So 3x squared plus 2x minus 8. And we get 3x squared plus 16x plus 20. Okay? Yeah. All right, so now let's go ahead and plug in. Don't put an equal sign, just plug in right now. So 3 times negative 2 squared plus 2 times negative 2 minus 8 over okay. And what do you get there? You still get 0. Well, you definitely get 0 on the top, and on the bottom you get 0 too. Okay, so we've got another indeterminate form. We do L'Hopital's again. 6x plus 2 over 6x plus 16. Okay, I think we'll be okay here. Negative 5 halves. Did you get that? Yeah. Okay, try 4 for me. Hopefully you have enough space. But you might want to use, yeah, you might want to use your calculator and store 5 in for x, because that's going to be hard to compute if you don't do that. But try 4, and then we'll do 5 and 6 together.
Something like 5 or x. But I don't know what that's. Look at where my finger is. That's not. You have to press the number store and that's the thing next to that. Well, you can do any letter, but.
Yeah.
And like, don't forget your limit statements, and to say this is an indeterminate form, and to say L'Hopital, like how you're doing L'Hopital.
I'm just gonna write heat.
I'm gonna get a space suit this morning. My handwriting's too big for this.
Yeah, actually, it's a little bit more space.
Wait, please don't
Yeah,
go
I
back.
can do it. This was we have to do it
Wait, like
7
3
times.
times? Yeah.
Is the delta math gonna be like that?
There's no delta math on this.
Yeah. If there's a double yes. on this, I'd be
Yeah, 100 seconds
Wait, is
to
there
like do the.
Oh yeah, after
So I got it done, but eventually I like figured out.
once you have the pattern, but it was good to help you. I mean, it sucks.
Yeah.
But like, it does help you find patterns.
Yeah, I got the pattern going, and so it was just more about recognizing the negative, the like
Yeah.
outside coefficient, and then just like what the like trig function
Yeah,
was.
what the derivative
The
of
inside
trig
part, like I think they relatively kept the same.
Yeah, like if it's 2x, it'll be a 1/2.
Yeah.
Oh my god.
So you don't have to waste time like actually calculating.
Yeah, but it's good for you to like get the pattern now, and so now on like the multiple choice test.
Garlic chili.
Yeah.
It sucks. I agree.
It took me like I failed at least like 8 times before I actually
Yeah.
got it going.
But it like really does make you better. Did you get does not exist?
Yes. I'm very disappointed.
All that work for DNE. I would do it, but I don't have room on here. Okay, I saw a lot of you didn't write limits in front of these, so they would mark it wrong. On multiple choice, you do whatever you want to do. But on free response, make sure, because they're grading your ability to like prove your reasoning. So make sure you write like the limit statements. Make sure you write indeterminate form. You plug in and you get a 0/0, and then like say you're doing L'Hopital's on free response. So just spend the time to do proper notation on free response. But on multiple choice, you go as speedy as you want to through it, okay? All right, now let's throw a couple of trig functions in, because you really can't solve either of these limits by factoring it anymore. But, I mean, the good thing is, if we get 0/0, we're only going to have to do one L'Hopital's for this one, because the derivative of the bottom is going to be 1, so we can't get 0/0 again. But let's plug in. First, 0 squared sine 0 plus cosine 0 minus 1 over 0. And don't write an equal sign. If you do write an equal sign and you get 0/0, then just change the equal sign to an arrow. That's what I usually do. So try not to write it, but if you do, just change it to an arrow. Okay, so now we have an indeterminate form. Okay, which means that we can do L'Hopital's. We can find the derivatives of the top and the bottom. The bottom's 1, and then the top, I'll have to do product rule to take the derivative. So 2x sine x plus x squared cosine x plus, oops, I should do minus, right? Minus sine x, and then the derivative of 1 is 0. Okay, now let's plug in 0. So 2 times 0 is 0 plus 0 minus 0 over 1. That's okay. We don't have to do L'Hopital's again. We just get 0 as our answer. Okay. All good? Yes, Jordan.
How did you get x squared cosine x?
Oh, because you have to do product rule with this.
Oh.
It's
okay.
x squared times sine x. So you do first, second, first.
Okay, and then also just another question.
Yeah?
If we could just sort of look at it and realize it's going to be 0 over 0, do we have to write out how we're plugging it in?
Probably not. Like, I mean, I think if you wrote like 0 over 0 and you said indeterminate form, it's okay.
Okay.
But if it's free response, just do it, just to make sure. This is the one where the grading is very tricky, and I don't like where they give you points.
Okay.
But we went to like this reading discussion last year, and they said specifically like that they were looking for this, and I don't want you to miss points on something that's like so easy. But I agree, it's like really lame and annoying to have to write it with zeros in. But we'll just try to maximize points where we can, and if that we know that's what they want to give you points for, then we'll just do it. Okay, for number 6, let's go tangent 0 minus 0 over 0 cubed. Tangent of 0 is 0 over 0. Okay. So we've got an indeterminate form. We'll apply L'Hopital's. And we go derivative of tangent is secant squared. Derivative of x is 1. And then this is 3x squared. This problem will challenge your trig derivatives. Okay, if I plug in 0, then I get secant squared of 0 minus 1 over 3 times 0 squared. So I still get 0 over 0, which is another indeterminate form. And we L'Hopital again. Yeah, we're either going to keep going until the x is gone in the denominator, or until we get a number on the top. I think it might be easier to rewrite this one, though. Instead of secant squared minus 1. Secant squared minus 1 is equal to what? Tangent squared, right? From that, those Pythagorean identities. Okay. The derivative of that is a little bit easier, but not too much easier. So the bottom is 6x now. And then the top will be 2, this is a chain rule, 2 tangent x to the first times secant squared x, right? Okay, and then we plug in 0 and I get 0 over 0, which is another indeterminate form. Okay, so the next part, yeah, this is not very fun. I'm sorry. But at least you only have to do it one time. I have to do it 3 times this year, and then for the rest of my life until I retire. So just take solace in that. Whatever nasty things I make you do, I have to do it for 15 more years. Times 3. Does that make you feel any better? No? Yes?
Oh, that's a long time.
What? Because I have to do product rule.
Yeah.
Okay, so yeah, and chain. 2 derivative of tangent is secant squared. Secant squared. That second one stays there. Plus 2 tangent x. And then this secant squared becomes 2 secant x times, and then the derivative of secant x is secant x tangent x over 6. Okay, at least we're done here. I mean, there's no more after this. So 2 times 1 is 2, plus tangent is 0, 0, so that's 0, all over 6. So you just get 1/3. Okay, that's nice. That was fun, right? Good times had by all. Okay. Yeah? No. Problems on the test, you'll probably have to do 1, maybe 2 L'Hopital's, but just 1 usually.
How big is L'Hopital's in the AP?
How big is it?
Yeah.
Well, they'll definitely, they added it on, well, no, it's definitely always on BC.
Yeah, it was on AB last year.
And yeah, and they definitely added it on AB because that was one of the most recently added things to the curriculum. So it's going to be on there. Okay. Do you remember inverse trig functions? Meh, kind of. Yeah, you definitely learned them. Like, basically, like inverse sine of root 2 over 2 is pi over 4, right?
Oh yeah.
Yeah. So sine, like inverse sine is just like inverse sine of the answer equals the angle, right? Okay, well there's derivatives of inverse trig functions, which are not so fun. But the good news is you only have to know arcsine and arctangent, or inverse sine and inverse tangent. Arcsine and inverse sine mean the same thing. Yeah, you don't need to know it. I don't know why they don't make you know it for the test, but they don't. Nope, they don't. You get no formula sheet.
Then why do you not?
Because they won't ever test you on them.
Oh, there are no questions on it?
There's no questions on arcs, cosine, cotangent, cosecant, or secant. What? One over inverse sine is cosecant to the negative 1. No, you have to write cosecant to the negative 1.
But so how do you not?
Then does that become like sine?
What do you mean?
Like the sine squared x, the sine to the negative
1 over sine is cosecant. That's it.
What if 1 over cosecant is sine?
Yes, exactly.
So then cosecant to the negative 1.
No, it's not to the negative 1. This is inverse. Then
From context, you know about negative 1 always.
just, guys, this is not pre-calc anymore. And we're not going back into like the 18th century and redefining arcsine and sine inverse. This is what they've said it is, and this is what we accept as, because that's just what we do. Maybe you're wrong. Ever think about that? Okay, let's start. Now this is where it comes from, so I'm just giving you the reason why the inverse trig functions are this formula down here. But you don't have to memorize how to do it, just this. I figured I'd explain why. Okay, so if y equals arcsine x, then sine of y equals x, right? That's the definition of the inverse for trig, right? Okay, now, if sine of y equals x, then let's make y our angle. And then label my sides of my triangle. This side right here would be opposite, which is x, and then the hypotenuse would be 1, right? Okay. Help me find this bottom side. Solve the triangle. Okay. You guys, I'll help you. Starts with the square root.
Wait, is the angle y? Like, do you
Yeah, the
know-
angle is y.
So do you know the angle?
You don't know the angle.
Oh, okay.
You just do Pythagorean theorem. C squared minus b squared, and then square root, right? Oh gosh. We're struggling today. Okay. Now, let's take the derivative of sine y. It's, what is it? Okay, cosine y, not done. Cosine y what? OMG. Implicit, because we took the derivative of y. So then, what is the derivative of x? 1. Okay, cool. So dy dx equals 1 divided by cosine y, correct? Yeah? And then, what is cosine of y using our triangle? Yeah, adjacent over hypotenuse, but since it's 1 over, let's go hypotenuse over adjacent. And that's the derivative of inverse sine. Square root 1 over square root 1 minus x squared. That's this. But it has u's instead of x's because of chain rule. Because if there's something inside for x, you have to take the derivative. You have to multiply it by the derivative of what's inside. Shall we do inverse tangent? I don't know why I wrote arcsine again. Let's write arctan here. Okay, cool. If y equals arctan x, then tangent of y equals x. Now what do I do? Okay, if you want, we can take the derivative. Derivative of tangent is secant squared y dy dx equals 1. And then, so dy dx will equal 1 divided by secant squared, or we can just say cosine squared y, right? Yes? Okay. But that doesn't help me. Where's the formula? I need to draw my triangle. And we'll start with what we know. We know this is y, and we know tangent of y is equal to x, which means opposite over adjacent. Okay. And so my hypotenuse is square root of x squared plus 1 squared. Usually they write the 1 in front, but you can do it either way since it's plus. 1 plus x squared. So the derivative of arctan is cosine squared y. So it becomes adjacent over hypotenuse squared. So just 1 over 1 plus x squared. Cool. That's the derivative of arctan. Or if you want to do it with u's and have chain rule, then it's 1 over 1 plus u squared times the derivative of what's inside. So you can remember one or the other. That's fun, right? So you only have to remember arcsine and arctan. And the other ones I put here so that if you use this book later and they want you to know it, you have it there. But unnecessary for you to know. Arc cosine is the same thing as arc sine, only with a negative. So I don't know why they don't have you learn that one, because it just makes, like, intuitively it makes sense, because the derivative of cosine is negative sine, right? And then arccotangent wouldn't be too hard to learn either. It's the same thing as arctangent, but negative. Anyways, we will.
It's the exact same thing.
What?
No, never mind. I
One is
fixed it.
positive and one is negative, right? Yeah. Okay, let's cross out the bottom two because we haven't done exponentials yet. But let's take the derivative of the top two. And it's not even that difficult. You just need to know that the derivative of sine is 1 over square root of 1 minus, and then whatever's inside squared. So it's 1 minus, and the inside of inverse sine is x squared. So squared. Right. And then I have to multiply by the derivative of the inside function, so times 2x. So if I simplify this, we would just move the 2x into the numerator, and then simplify the denominator to 1 minus x to the 4th.
If you remember the formula from above, just go straight to that.
Formula from above?
Like from the
Yes. Oh, the u one?
yeah.
Yeah. Yeah, let's try it for the second one. So it'd be the 2 we can put on the top as well, and then u prime is 3 over 1 plus, there's no square root for inverse tangent because you square the secant, so 1 plus quantity 3x squared. Or you can simplify it to 6 over 1 plus 9x squared. Okay. Good? All right. Now let's go to integration. Integration, not so easy. Well, in general, it's not so easy. But with inverse trig, it's even harder. Yeah.
Are you saying that they're not all going to be nice?
No, and sometimes they have it so that it's not just integral. Like, this is easy. If I asked you to just do integral of 1 over square root 1 minus x squared dx, that's what? Yeah, arcsine, right? And if I asked you integral of 1 over 1 plus x squared dx, then you just say arctangent, right? But it's not always that easy. Here's an example of sometimes what they'll do. They'll do 1 over square root of 4 minus x to the 4th integral. Okay, now it's no longer like a 1 here, it's a 4, and then they have an x to the fourth, and you can't do u sub because your first instinct would be to say, oh, u is 4 minus x to the fourth, and so du is negative 4x cubed, right? But you don't have a negative 4x cubed in the numerator, so you know you have to do an arc sign. It's got to be an arc sign. But this 4 isn't a 1. So mathematically, this is how it works. But then there's a formula you can do it this way, or there's a formula you can memorize, whichever one you like better. So this is equivalent to, if I brought out a 1 over square root 4, and I just factored it out from my integral, what would be my denominator if I took out a 1 over root 4? So what would this be? If I took out a root 4, then that would be 1, right?
Yeah.
And then if I divide by root 4 here, then this would be minus x to the fourth over 4, right? Are you with me? Yeah? Kind of? It's basically like I divided out of 4, factored out of 4. But I had to leave it inside of the root because it was inside of the root. Okay. Same thing as 1/2. Let's simplify a little bit. Integral of 1 over square root of 1 minus, and then what to the power of 2? X squared over 2. Oh, farts. Can't do it. Gotta make this an x. Sorry, guys. Make that an x. Because then we can't integrate it. I'll show you why in a second. Okay. This is now our u. What's du? Just x, right? Okay, there it is. That's why I had to have this top be an x, because x dx cancels out with that x dx, right? Okay, so now then I have 1/2 integral of 1 over square root 1 minus u squared du, and that is inverse sine. Okay. Not too easy. All right, do you want to do an arctan one? Well, maybe you don't want to do it, but like, should we do an arctan one? Yeah.
How did you get from the square root of 1 minus x to the fourth over 4, like the x to the fourth over 4 to x squared over 2 squared? Is that just...
Basically, I was just like, oh, if I took out, like, because it has to be something squared to be part of the 1 minus u squared, 1 minus x squared. So I had to figure out, like, what the thing was to square. Okay. And then let's do an example of arctan, even though I know you don't really want to. Okay, 1 over 9 plus x squared dx. So what should I take out? Because this 9, I want it to be a 1. I want it to be a 1
Miss
here.
Molly, are we not
Yeah.
using the two formulas at the top of the page?
What?
Are we not using the two formulas at the top?
No, I'm showing you that you can do it this way, or you can do the two formulas, memorize the two formulas on the top of the page. Okay, so this, if I rewrite it, is 1 over 9. Take out a 9. And then that would be 1 plus x squared over 9, right? Which is the same thing as 1/9 integral 1 over 1 plus x over 3 squared. And then so if u equals x over 3, du equals, what should I do? 1/3, right? So then I will multiply 1/9 times 3, right? Because of this du. So I get 3/9 integral 1 over 1 plus u squared du. And the integral of 1 over 1 plus u squared is inverse tangent, so 3/9 is 1/3 inverse tangent of x over 3 plus c. Yes?
Wouldn't it be dx equals 3 du, and therefore we have to divide du by 3 and there take out 1/3?
U equals x over 3. Du is 1/3 dx.
So dx equals 3.
Yeah, so I multiply by 3.
Wouldn't you divide by 3 to take out?
If du is 1/3 dx, then 3 du. So I put the du back in and the 3 on the side. If it was 3x, like if u was 3x, then du would be 3 dx, and then I would divide by 3.
I don't know why I was thinking you have to divide. You don't have to divide by the coefficient. You just have to take out the coefficient of du.
Yes, the coefficient of du. But you divide by the coefficient of dx. Like if you left the 1/3 with the dx,
Oh.
then you would divide by 1/3, which would be multiplied by 3. Yeah. Okay. You can learn this way and do it this way. That's totally fine. If you like it like that, do it like that. But if you don't like it like that and you just want to memorize a formula, then this is the formulas that you should memorize. The integral of du over, if you have something squared minus something else squared, then the inverse sign is just the u over the a. Make sure you do chain rule if you have something in, sorry, not chain rule, u sub if you have something else in for u. And then inverse tangent is u over a, but then you end up having this 1 over a in front because it doesn't cancel out. So if you want to do it the first way, you can. If you want to do it the second way, you don't have to. One we already said was inverse sine. 3 we already said was inverse tangent. Okay, I'll show you how to do 2 if you memorize the formula way. This would be a would equal what? 2, and u would equal just x, right?
Is A always a number?
Yeah. So I have a du of what? Just 1 dx, right? So we don't have to worry about u sub. So we can just do this would be equal to inverse sine of u over a plus c. But if I had something other than 1, I'd have to divide by that number out in front. Okay? Let's discuss 4. So if you use the formula, this would be inverse sine. 5 is your a would equal what? Root 5, good. And u would equal, yeah, I'm going to go x root 2 because it's nicer to put the variable on the outside of the root. Okay, do I have a du other than 1? I have root 2 dx, right? Okay. That that means on the outside I have to put a 1 over root 2 because I have a du. And then this is inverse sine or inverse tangent. This one with the root and the minus is inverse sine. And then it's u over a. You don't have to rationalize. Okay. 5. Make this a plus, please. Yes, thank you. So for 5, change that to a plus really quick for me. Let's do u and a. A is root 5. U is
Why
x
is it root 5?
because the formula, good question, Jordan. The formula is something squared, and this is something squared. Okay. It has to be some number squared. So since it's just a 5 down there, then it has to be root 5. See, for all the ones that we did before, like these were perfect squares, so that's why we ended up with a 2 here. And this 9, we ended up with a 3
So
down.
they were like already in a square root.
They were all, yeah. This one was like the 4 and the 9 were already perfect squared. So my numbers down here were 3 and 2.
So if they're perfect squares, you don't have to take the square root?
No, you do,
But,
because the square root of 4 ended up with a 2,
okay.
and the square root of 9 ended up with a 3. Because when you take the 9 out,
So do you just disregard the square root that's above all of it?
yeah, that's part of the inverse sine part. Yeah, I know this is, it's just going to take some practice. Okay, that's u, that's a. I have a du of root 2, which means that I should pull out a 1 over root 2. And then this is going to be inverse tangent. And then u over a.
You also have to pull out
Let's see.
1 over a.
No. Oh, yes, I do. Sorry. For inverse tangent, I do have to pull out a 1 over a. For inverse tangent, oh jeez, my thing messed up. For inverse tangent, the formula has a 1 over a in front. So just be very careful that you have to pull that out too. 6 is interesting. Don't write this down yet, but this would be my first thought for 6. I would say, oh, I've got an x on the top. Let's first try u is 4 minus x squared, but du is negative 2x dx, and that doesn't cancel perfectly with this x plus 2. It would be nicer if there was like a factor of x plus 2 right here, but it doesn't. So I can't do u sub, and I can't do inverse trig yet. So the only thing I can do for number 6 is to split it up. So this one has x over root 4 minus x squared dx plus 2 over 4 minus x squared dx. I just distributed the denominator to each part. Okay. I'm going to come over here and do this one over here. The first one, I can solve by u sub by letting u equal 4 minus x squared. Because see how I have this x dx right here? And that cancels out with this x dx right here. So I've just got the -2 left, so I'll bring out a -1/2. And then it's integral of 1 over u to the 1/2 du. Okay, that's not an arc sine one, because I can just do normal u sub. So the integral of u to the -1/2 is 2u to the 1/2, right? Which equals square root of 4 minus x squared. Okay. That's that part of the integral.
What about negative?
Yeah.
Oh, thank you. Need the negative. Let's do this part now. Right here. And so this 2 can come out, and then it's integral 1 over root 4 minus x squared dx. Now you can do what we did before. We did it with arc sine before, like on the previous page, and got the answer. But if you like the formula part, then a is what? And u is, which means du is 1 dx. We don't have to worry about pulling out another coefficient. So now it's just, what's our answer for that? 2 sine inverse of u over a, x over 2, right? And that's the second part of your integral, and then these two are added together, so it's just this plus this, and then just do one giant plus c, 1 plus c to rule them all. And then there's your answer. That was a lot.
Whoa. Why
Whoa,
can't
whoa,
you just, when you split it up,
Yeah.
why can't you just do the formula for both sides of the integral?
Oh, why can't I do, because I've got an x on the top. So you can't do it when you have an x on the top.
Okay, so you have to do the long way.
Well, it's not a long way, it's a different way.
Oh, you used to use some.
I just did regular u sub, yeah. Because u could be 4 minus x squared, so du is -2x dx, and that x dx canceled out with that x dx in the numerator.
But if x,
Yeah.
if u was a higher power,
If u was a higher power,
so when it wasn't x squared, it was like x to the 4th.
oh, if the top was x to the 4th, right here,
No.
Here?
Yeah, if that was x
if this was x to the 4th, then I would do inverse sine, yes.
But the x on top would also be,
Just an x.
there would be an x there.
There would have to be an x there, because u, if you were going to do inverse sine, u would be, if you were going to do an inverse sine with this being x to the 4th, u would be x squared.
So then
So
that'd be
du
2x on
is
top.
2x, and the 2x cancels, the x dx cancels with that x dx. Yes, good. Michael. There's no 1 over a for inverse sine. There is for inverse tangent. The inverse sine one, the 1 over a ends up canceling because you have a root there, and the inverse tangent doesn't because you don't have a root. That's why.
So
Yeah.
if there's a variable in the numerator, can you not do it? Do you have to do it the first way? Like how we did the use of?
That is a tricky question. Like,
I don't know.
it all depends.
There's no way
Here, like for example, if I gave you integral of equals 1 plus x to the 4th dx. Here's an example. If it was x cubed on top, then I would just do u equals 1 plus x to the 4th. I would not do an inverse tangent because du is 4x cubed, right? And 4x cubed cancels with the top. If the numerator said x squared, then I would do an inverse tangent because u is x to the x squared, right? No, sorry, you would just have to say x on the top. U is x squared, du is 2x dx, and there's your x dx that would cancel out with that x dx. Okay, so if it's x to the 3rd, you just do normal u sub. If it's just x dx, then just inverse tangent. Does that make sense? Like, for example, if I gave you that, what would you have u be? Oh, that's what du is. But u would be 1 plus x to the 6th, right? But if it said this, then you would do arctan because your u is x cubed and your du is 3x squared. Do you see the difference? Okay. It's kind of like if your exponent is always 1 degree less, then you just do normal u sub with let u equal the denominator. But if your exponent is like half of it and then 1 less, then you do arctan. Don't stress too much. We have time to get this, and like I won't bombard you with hard questions right now on this because we'll practice a lot more. Okay. You have a worksheet for homework tonight, not Delta Math. So if you want, come pick up a worksheet from up here. You have 2 things that you can work on right now, because remember, corrections are due next class. You can either work on the homework or finish the Delta Math. Actually, 3 things. Homework, finish the Delta Math, or work on your corrections. No, this is the Delta Math is from the old stuff. Or you finished it already then?
I counted that wrong.
That is wrong.
That's the same.
No, it's not.
How is it not the same?
This is the same.
Yeah, I put that one too, and they marked that wrong because apparently it's not.
That's the same.
Oh, okay. Because if you do
Right.
the x, it counts as x.
Yeah. It squares the x first. I know, it's really annoying.
Yeah, it is.
That's the hardest part of that Delta Math is like, it's that, this thing. Yeah.
Now I don't know how I got it.
Okay, I can go over it with you. Give me 1 second. What's up?
What's wrong with
Oh, you have to interpret the meaning of your answer in the context of this problem. So you would want to say that the temperature is, it's positive, so increasing at a rate of 1.016 degrees per minute at t equals 12. Okay, so you gotta use your thing in your answer. So then you would want to say, the temperature decreased or increased by 16 degrees Fahrenheit from T equals 0 to T equals 1. I thought this one was like kind of okay, but really like that one should have been edited. Okay. So you made U is x over 2, right? So what's du? Now, what happened to this one half? It goes out here on the 2, right? And then that part, and this 2 cancels with that 2.
Yeah, it was a joke, Howard. It was a joke. It was a joke.
Yeah. Does that make sense? Okay. You're welcome.
Yeah.